what I should ask, what questions did you try to answer in your PhD that were different to your master's?
They were actually very similar, just a much bigger scale.
Mm-hmm.
So in the master's, I focused really on the performance, while in the PhD, I expanded it onto the actual mechanism. So it was really, is the performance improved following that living high, training low method?
Mm-hmm.
Yes or no? That was the master's. The PhD, I went into the mechanisms related essentially to oxygen carrying capacity. So all the red blood cells, EPO, and etc. And I added as kind of an add-on this security, safety aspect of it.
So can you just elaborate a little bit on the mechanism? We'll get into the security aspect.
The mechanism, the idea is, again, you go to high altitude to stimulate the production of red blood cells. So chronologically, when you go to high altitude, again, inverted commas, the lack of oxygen is making you breathe harder, which is a short-term response. A much more efficient and long-term sustainable response is to produce new red blood cells. So it starts with the release of EPO, and if the stimulus is sustained for long enough, then you will end up with new red blood cells. If you have more red blood cells, obviously you can carry more oxygen.
Mm-hmm.
So when you go back down to sea level, where you have the normal level of oxygen, all these extra red blood cells that you've produced will be here to help you carry more oxygen, deliver more to the tissues, to the muscles, for that instance, and your performance is supposed to increase. And that's really the chain of events that is behind it. Then the question is, how much altitude do you need? How high do you need to go? How many hours a day? How many days a week? Or how many weeks? So that was the kind of questions that we tried to answer, try to work out a dose of hypoxia, as it's called, a dose of high altitude that you need for that method to work. And really the point of these 3 studies were to try different protocols. So the first one, we didn't do too well in terms of performance. We actually targeted too high an altitude, which means that the athletes couldn't recover from their training sessions and they actually got fatigued. So the anecdotal results showed us that probably a month or two, all their physiological parameters were back down to normal, but they felt very good. They had very good sensations because they had finally recovered. But when we tested them at the end of the training protocol, we didn't see any improvement. Then the second one, we thought, okay, we'll go for a lesser altitude. So we went up to 3,500 meters for the first study. We didn't exceed 3,000 for the second one, but we actually were limited with time, so we had a shorter duration, which means that the overall dose of hypoxia they received was less. Again, didn't show great results. And the third one, we finally nailed it. So we limited the high altitude to 3,000 meters and had them for 3 weeks. And they spent about 15 to 16 hours a day in their room. And we had tip-top results. And really, they were, as you were saying, the 1-2% that they are looking for to get the gold medal. As a group, they definitely had that, achieved that. And we were also interested in how long the effects would go on for. So we studied them again 2 weeks after the end.
Right.
And interestingly, once you get the protocol right, what we observed is some parameters start to go back down, like the red blood cells are back down, but your performance is actually still improved.
Really?
And we thought that it would be because you have almost kind of a potentiation of the training. So when you go back, because you have this extra boost, your training sessions are that much more efficient, and you benefit from that a bit further down the track, even if all the physiological markers are back to normal. At least that was the idea that we suggested for that.
So how would the efficiency improve?
So what I mean by the efficiency is again just the training sessions. You are able to push yourself a little bit harder.
Okay, so they are able to train harder
Exactly.
and keep themselves at a higher level.
Yeah.
Okay, that makes sense. I thought maybe, because I thought technically they're probably doing the same thing. As in if they're trying to do a certain drill over and over again, but it's because they can do it better.
And you recover a bit better because again, you require the oxygen when you recover. So if you have more red blood cells, you deliver more oxygen to the tissues and you're supposed to recover better. Again, it's never been really tested, but that was the theory behind it.
That's the idea. Thanks for listening to Blab Codes. Rate and review our podcast on iTunes or wherever you get your podcasts, because it does help us spread the word. And if you like what we're doing here, then help us grow it by sharing this with a friend of a friend, or your mailman, even your mailman's mailman. We also want to hear from you, so send us questions or comments to blabquotes@gmail.com. And if you have any interesting questions or comments, then we'll talk about it on air.